Hi and good day. I am Dr. Raifa binti Rano. In this video, I will explain how to determine whether a function is an odd or an even function. At the end of this lesson, students should be able to determine even, odd, and neither even nor odd functions. Here are the properties of odd and even functions. Let a function be a real valued function of a real variable, then the function ft is an even function if f of minus t equal to f of t. Another property of an even function is the graph of the function is symmetric about the y-axis. The second one are the properties of an odd function. The first property is the function is an odd function if f of minus t equal to minus f of t. And the second one is the graph of an odd function is symmetric about the origin. Let's take a look at example 4.3. The first equation is ft equals t squared. It is an even function. Let's check the properties of the function ft. The first property, when we substitute minus t into the function f of t, that minus t in bracket squared, it is equal to t squared and equal to the function f of t. For the property 2, when we plot the graph of ft equals t squared, we can see that the graph is symmetry about the y-axis. The second function is ft equals t cubed. This is an odd function. Why it is an odd function? The first property, when we substitute the minus t into the function of f of t, we obtain minus t cubed, and this is equal to minus f of t. And when we plot the graph of f of t equal t cubed, and the graph is symmetric about the origin. In this table, I list down the examples of even functions and the examples of odd functions. Let's take a look at the examples of even function. Modulus t squared, t to the power of 4, t to the power of 6. Then I can say that the polynomial of the even power are even functions. Other than that, we have cos t and cos hyperbolic t. Remember that the property of even function is f of minus t equals to ft, and the other property of even function, the plot of the function is symmetrical about y-axis. Here are the examples of odd functions. So we have t cubed, t to the power of 5, a polynomial, okay, to the power of an odd numbers, sin t, sin hyperbolic t. Okay, recall that the property of an odd function is f of minus t equals negative ft, and the property 2 is the plot of the odd function is symmetrical about the origin. The next example, you are given a function ft equal to 1 plus t, where t from minus 1 to 0, ft equal to 1 minus t when t from 0 to 1. Okay, it is a piecewise function with two intervals, and it is a periodic function since ft plus 2, where 2 is the period of the periodic function, equal to ft. So it means that as t plus 2 unit or 2 seconds, the graph repeats itself identically. First question is sketch the function over the interval from t negative 3 to t equal to 3. The second question is determine whether the function is an odd or an even function or neither function. Here is the solution. Let's take a look at the first interval from negative 1 to 0. From negative 1 to 0, the plot of the function was 1 plus t looks like this. Okay, on the other hand, from 0 to 1, the plot of 1 minus t is as shown in the figure. Then we extend the plot from minus 3 to 3 by repeating the same plot. To answer the second question, we can see that the function here is a triangular wave function. It is a periodic function that it completes one cycle every 2 units or 2 seconds. Okay, since the function f of minus t equal to ft, and when we look at the sketch of the function is symmetric about y-axis, therefore the function is an even function. Here are some exercises that you can try on. Okay, let's try to answer all the questions to test whether you understand how to differentiate or how to determine whether a function is an even function or an odd function or neither, both of even and odd function. Thank you for listening. I'll see you in the next slide.